Okay, so now moving on to exponential decay. Exponential decay is when something decreases exponentially. So it starts out up high, so up high here on the graph, and then it decreases very, very quickly, and then again gets closer and closer to the x-axis, but never actually gets to 0. We're looking at the same formula, y equals a times b to the x power. A still represents the y-intercept. Let me switch over to pen. A is still the y-intercept, and b is now 1 minus the decay rate. We'll talk more about that, as I said, as we move forward in future lessons. But basically, your b value is now going to be a number less than 1 because you're subtracting from 1. So it'll be either a fraction or a decimal that is greater than 0 but less than 1. Okay? So just to compare the two, exponential growth versus decay, the red graph is the growth, exponential growth, and exponential decay is the blue one. And we read the graphs from left to right. So on the red one, you're starting out small and you're getting bigger and bigger and bigger. And on the blue, you're starting out really high and getting lower and lower, 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 smaller, smaller. Okay, so just to compare graphs here, in example 3, you should be able to look at the equation of an exponential function, and just by looking at it, you should be able to determine if it's representing exponential growth or decay. The place you're looking is the b value. So here I'm looking at the b value. Since it's smaller than 1, this tells me that this is exponential decay. Okay, and again, the 2 is the y-intercept, so that's not determining whether it's growth or decay. And then in part B, I'm looking at the I'm looking at the b value again, which is once again, I'm trying to use the highlighter, which is 3. And so since 3 is bigger than 1, if the b value is greater than 1, then that's representing growth. Okay, so this is because b is greater than 1, this is because b is less than 1. To graph an exponential decay function, you're going to do exactly the same thing. You're going to set up a table of values, and you're going to go typically -3 to +3. Okay, so -3, -2, -1, 0, 1, 2, 3. You may or may not use all these values. So when I plug in 1/3 to the -3rd power, that's the reciprocal, 3 cubed, which is 27. This is 1/3 to the -2nd power, the reciprocal, which is 3 squared is 9. 1/3 to the -1st is just 3. 1/3 to the 0 is 1. 1/3 to the 1st is just a third. 1/3 squared, you do not need a calculator. You're squaring the numerator and squaring the denominator. So that's going to be 1/9. And same thing with 1/3 to the 3rd. It's faster than the calculator. 1 cubed is 1. 3 cubed is 27. Okay, and those are those decimals that are very close to the x-axis. So we have -327, I'm not going to graph, -29, 1, 2, 3, 4, 5, 6, 7, 8, 9, that's here. -1, 3 is here. 0, 1. Again, remember that y-intercept was that invisible 1. 1, 1/3. And so these are the values that get closer and closer to the x-axis. So I'm starting out up high and continuing with the curve approaching the x-axis, approaching 0, but never reaching it, which we'll take a look at on the graphing calculator also why that happens. So I'm going to label y equals 1/3 to the x power. Okay, we'll do one more. If you see a decimal, you may want to change it to a fraction. It's actually easier to work with. So 0.5 is 1/2. So if you ever come across this situation, it's because then you can take the reciprocal, right? And you can do it a lot faster than on your calculator. So I'm going to do the same thing, x, y. So I have -3, -2, -1, 0, 1, 2, 3. And I'm just plugging in values. So 4 times 1/2 to the -3rd. Well, the reciprocal of 1/2 is 2. And 2 cubed is 8. So 8 times 4 is 32. Okay? And then 4 times 1/2 to the -2nd. So the reciprocal of a half is 2. 2 squared is 4. 4 times 4 is 16. This is 4 times 1/2 to the -1st. The reciprocal of a half is 2. 2 to the 1st is 2 times 4 is 8. So based on the grid I gave you, that's the first one we can graph. 4 times 1/2 to the 0 is just going to be 4 times 1 is 4. 4 times 1/2 to the 1st is just 4/2, right, which is 2. 4 times 1/2 squared is really 4 times 1/4, and 4 times 1/4 is 4 over 4, which is 1. And then 4 times 1/2 to the third is 4 times 1 over 8. 4/8 is a half. Okay? So negative, I can't graph these. I'm going to start with negative 1, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then 0, 4. 1, 2, 3, 4, which makes sense because my y-intercept, my a value is 4. 1, 2, 2, 1, and then 3, 1/2. Okay? Again, they all have the same exact curve shape, right? So that tells you if you're doing something right or wrong. Y equals 4 times 1/2 to the x power. All right, everybody, so this allows you to complete your homework for tonight. Please remember to submit it on Schoology. All right, thank you.